Hello everyone, this is Vandita. I am studying in Sri Venkateshwara College of Engineering, Bangalore. Currently pursuing my third sem in the branch Computer Science, that is specialization in data science. Today, let's discuss with the topic test of significance for comparison in large samples. This is a topic in mathematics for CSE stream for engineering students. Let's discuss the test of significance for comparison of large samples. First, let's discuss large sample test. Large sample means a size greater than 30. The large sample is defined for a size which is greater than 30. Z-test is generally applied for large samples. Z-test is a statistical test for approximating normally distributed table. Because of the central limit theorem, many tests satisfies are approximately normally distributed for large samples. Conditions to be fulfilled for Z-tests. The data are drawn using simple random samples, which is also known as SRS in short, for the population of interest. The sample size is large, at least 10 times as large as the sample, and or the population variance, that is standard deviation, is known. These are the three conditions that has to be fulfilled for Z-test. Note, this is a major important note. If the population variance is unknown, the sample of ST maintains. The following tests are discussed in large sample tests. First one is test of significance for proportion. Second is the test of significance for difference between two proportions. Third is the test of significance for mean. Fourth is the test of significance for difference. Fifth is the difference between two means. These are the following tests discussed in large sample test. Next, let's discuss a large sample test hypothesis. Let's discuss a step-by-step procedure for large sample hypothesis. First, identify the null hypothesis, which is usually denoted as H naught. Mu equal to mu naught. Identify the alternative hypothesis that must be true where the original claim is false. For one-tailed test, mu is greater than mu naught, or HA, mu is lesser than mu naught. Once null and alternative hypotheses have been formulated for a particular claim, the next step is to compute a test statistic. The appropriate significance test is known as the Z-test. Calculate the test statistic Z-test. Select the significant level based on the seriousness of a type 1 error. The values of 0.5 and 0.1 are very common. These are the two different values which are very common in the result during the error. This is the step-by-step procedure. Let's discuss further. Determine the critical values and the critical region. The graph for a statistic, critical value and critical region. Then reject H naught is the test statistic in the critical region. Fail to reject H naught if the test statistics is not in the critical region. Restate this decision in simple, non-technical terms. Next, let's discuss the test of significance for proportion. A hypothesis test of proportion can be done when the following conditions are met. Sample space, simple random sampling, which is known as SRC. Each sample point can just in result two possible outcomes. Either success or failure can be the two possible outcomes. Next, the sample includes at least 10 success and 10 failure. The population size is at least 20 times big as the sample size. Next, let's take an example for this test of significance. First example is ABC Bus Services claims that 90% the bus reaches the destination on time. A consumer group passengers and found that only in 192 out of 250 passengers reported that bus on time. Is it claim for the bus service valid? So here there is a bus service that 90% bus reaches on time. Then a consumer group passengers and found only 192 out of 250 passengers. So at particular time, only 192 out of 250 passengers were reported on time to climb the bus. We need to see if the bus services is valid or not. We know that H naught is the proportion of bus reaches on time is equal to 0.90. That is 90% divided by 100 will get 0.90. Then proportion of bus reaches on time is not equal to 0.90. That is H1 value. We are given N equal to 250. Observed proportion in the sample is equal to 192 divided by 250. After calculation, simplification, we get the value 0.79768. That is observed proportion in the sample. So actually buses reaches on times are 76.8%. So the total average percentage that bus will reach on time is 76.8%. Next, but in this question, it is 90%, which seems to be untrue. So there is no chance of 90%, that is usually defined as untrue. Let us statistically check the using z-test as the large sample. So using z-test, when we check the sample, the result will be generated. Since the calculated z0 value is greater than ze value, that is observed value is greater than expected value, we reject the hypothesis. So in which case do we reject the hypothesis? This is the answer. When observed value is greater than the expected value, we reject the hypothesis at 5% level of significance and conclude that claim of bus services is an invalid. That is, bus reaches destination on the time is less than 90% of the sure. Next, let's see example 2. In a random sample of 800 toys from a large toy shop, 240 toys were for playing purpose. Can it set the toys to be kept in showcase and toys for playing purpose are in the ratio of 5:3 in the population? Use 5% level of significance. So in this question, we have given that total number of toys is 800. Out of that, 240 toys were designed for playing purpose and rest for keeping just for showcase. So the ratio is 5:3. So now we need to use 5% level of significance and calculate the answer whether the hypothesis is rejected or accepted. So the H0 proportion of playing toys and showcase toys in the population are in the ratio 5:3. Next, H1 proportion of playing toys and showcase toys in the population are not in the ratio 5:3. So H0 is in the ratio, H1 is not in the ratio. So the solution for this is we are given N equal to 800. So the total number is 800 toys. Observed proportion of playing toys in sample is 240 divided by 800. That is 240 is playing toys and 800 is the total number of toys. That is 0.30 proportion of toys. After calculation, we get the final answer as 0.375. So the result is calculated value, that is z0 value is greater than ze value, that is expected value. So we know that when observed value is greater than expected value, the hypothesis is rejected. So we need to calculate at 5% level of significance. So null hypothesis at 5% level of significance is rejected. And we conclude that the proportion of playing toys and showcase toys in the population are not in the ratio 5:3. Hope you have understood all the topics which I have explained previous. Thanks for watching. Please do share, like, and subscribe for my videos. Thank you.